So we move into the next phase of today's lesson, and really the guts of today's lesson, because if you can understand this, you're going to understand everything we do throughout today's lesson. Quartiles and percentiles. Quartiles and percentiles are very popular. In fact, they're the most common way to preserve or to measure the location of data. And by that, I mean the location of data relative one to another. You probably heard about percentiles in class rank in high school. For instance, when I was in high school, I graduated 7th out of 276 students. My class rank was 7th, but that really doesn't tell you very much. I now live in Callicoon, New York, where we graduate about 15 students a year. So if all I considered was my class rank, well, in Bayport, class rank is 7th. And if I would have graduated in Callicoon, I would have graduated also 7th, say. But in Bayport, my percentile was 97.5%. What that means is that I performed better in high school than 97.5% of the students in my grade. If I was in Callicoon, I would have performed better than 47% of the students in my grade. So percentiles and quartiles lend context to order. It's very important. Without it, you don't get a complete picture of order. For example, someone might say, wow, that's pretty impressive. You graduated 7th in Bayport. But in a neighboring district called Sachem, at the time, Sachem was the largest suburban school district in the United States of America. And I believe in every year, they graduated over 1,500 kids. Imagine if I was 7th out of 1,500. That's almost the 99th percentile. So that really does mean a lot in terms of, by that I mean the quartiles and percentiles mean a lot in terms of where we are ranked. Sometimes we go for the quick, easy, recognizable percentiles, say the 25th, the 50th, and the 75th. And they're really convenient to work with. These are called quartiles. The name quartiles should remind you of quarters, right? And 1 quarter is worth 25 cents, 2 quarters worth 50 cents, 3 quarters 75 cents, and so on and so forth. So let's get to work with this. What percentile is the score 88? 10 students were tested. The results are, what percentile is the score of 88? Well, the first thing we need to do is we need to rewrite these in order. Whenever we're talking about percentiles and quartiles, order is extremely important. In fact, if you don't have order, you have chaos, and chaos on a test is not a good thing. Okay, so here they are rewritten. Oh, no, sorry about that. Here they are rewritten in order. Now, the score of 88 ranks 8th out of the 10 scores. Here's the 88 right here. So it's 8 out of 10 scores. 8 out of 10 is 0.80 or 80%. Just do the part over whole and convert to a percent. So if there were 100 scores and the 88th score was, say, or a score of 88 was, say, the 79th score, you would do 79 over 100 and you'd have 79%. In this case, it's the 8th out of 10 scores. So it's the 80th percentile. Okay? Quartiles can be thought of as a study in applying medians. You're actually going to do medians 3 times when we start talking about quartiles. Quartiles are numbers that separate the data into quarters. Okay? Quartiles may or may not be part of the data. To find the quartiles, first find the median or the second quartile. The first quartile is the median of the lower half, and the third quartile is the median of the upper half. To get the idea, consider the same data set. There it is. First, find the median of all of those numbers. There are 10 numbers here. Is it 10 or 12? What do we got here? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers. So you want to find the median of those 14 numbers. And remember, the median is always ordered. It's the one in the middle. But if there are 2 numbers in the middle, you got to find the average of them. That means add them up and divide by 2. So for instance, if in the middle of this were 10 and 20, you would take the average of the 10 and the 20, which would be 15. Add them up, 30 divided by 2, you get 15. Okay, so find the median of these numbers. We'll do a little stop and start here. Okay, so those are the 2 in the middle. There's 14 scores, so that means the middle guys are the 7th and the 8th scores. If you wanted to, like, you could cross off numbers from each end until you wound up at the middle. Or you could say, look, there's 14 scores. Half of 14 is 7, but there's not 1 in the middle. So it's 7, 8. Because there's an even number that has to be 2 in the middle. So what's the average of 6.8 and 7.2? I got to add them up and divide by 2. I do that, I get 14, I divide by 2, I get 7, and that means the median, or the middle quartile, or the second quartile, whatever you want to say, whatever you want to call it, is 7. Okay. Now, the minute you do that, to find the lower quartile, you do the same exact thing you just did. There might only be 1 in the middle. You might not have 2 scores in the middle, but you do it to the lower half of the data. So look what we did right there. I drew this line under the first half, or the lower half of the data. And now I'm looking for the middle term here. There are 7 scores here: 1, 1, 2, 2, 4, 6, and 6.8. Remember, 7.2 starts the upper half of the data. The one in the middle is the 2 right here. There's your 2. So that would be the lower quartile. So how hard is that, right? You do the median of the big set of data, then you do the median of the little set of data to get your first quartile. And then, notice the notation, Q1, first quartile. Then we find the upper quartile, or the third quartile. We do the same thing to the upper half of the numbers. So, you can see I underlined them there. I'm going to find the middle of those scores. I find the middle of those scores, it's going to be, there it is. It's going to be 9. There it is. Okay? So in other words, you find the middle of all the scores, and then you look at the lower half of the scores and you find the middle. That's the first quartile. Then you do the upper half, and you do the median of those, the middle of those, and you have your third or upper quartile. Now, the number 2, which is part of the data, is called the first quartile. That means 1/4 of the entire set's values are the same or less than, and 3/4 are higher than it. It's the 25th percent. The upper half, the value of the middle value of it, the median of the upper half, the third quartile, is 9. That means 3/4 are below it, and 1/4 is above it. So look at where we're at again. This is the lower quartile. 1/4 of the scores is below it. 3/4 are above it. With the upper quartile, 3/4 are below it. 1/4 is above it. Okay? The interquartile range. Now, this is a new terminology here. It's a number that indicates what the spread is like around the middle. What's the middle half of the scores? The ones that are closest to the median in the middle, the 50% of the data. Well, to find the interquartile range, we already know range means highest minus lowest. So we just do the third quartile minus the first quartile. Okay? So that's how we find interquartile range. And the last thing we'll talk about is called outliers. We'll get to that in just a minute. So here is the data that we just did before. We found out that the minimum value was 1. The maximum value was 11.5. I'm being a little bit careless with this, but we're going to go with it. Smallest number on the list was 1. Biggest number was 11.5. We found out the median was 7, the second quartile. Then we found out that the first quartile was 2, and the third quartile was 9. And there they are, all placed on the graph. Now, this piece in the middle, that's your interquartile range. And I just want to be clear on something. Back in the day when I did this, the first quartile was written Q1 capital. I noticed that they used that sometime here. Look here, Q3 for third quartile. But then in the interquartile range formula, it has a sub 3 and a sub 1. So we'll be able to recognize it both ways. Okay, so back to what we're talking about. Interquartile range is these numbers around the median. The interquartile range is the third quartile minus the first quartile. So the third quartile is 9, the first quartile is 2, 9 minus 2 is 7. So what that means is that 50% of the scores are clustered within a range of 7 around the median. Okay? Now, as far as outliers go, this is strictly a definition thing. There's not a lot of understanding to do with it. Why do we drive on the right-hand side of the road? I don't know. Somebody came up with it. That's how we do it, okay? How come we go on green and we don't go on red with the lights? That's just the way they figured it out. That's how we do it. And likewise, with respect to this figuring out outliers, they use what I'm going to term, this is not a technical term, the outlier factor, which is 1.5. So in other words, potential outliers are 1.5 times the interquartile range below or above. Below the first quartile, above the third quartile. In other words, they're out here somewhere. If they're more than 1.5 times above that interquartile range, like let's just say the last score here was 1,000, we would say, man, that's way out there. That doesn't make any sense. That would be called an outlier, okay? So let's see in this case. 1.5 times the interquartile range, which is 7, gives me 10.5. So let's see if there's an outlier in the low end of this data. The way you find to see if there's a quartile on the low end is you take the first quartile, a set of quartile, if there's an outlier on the low end. You take the first quartile, which is 2, you subtract that outlier factor, which was 1.5 times whatever the interquartile ratio is, or interquartile range, and that's 10.5. And that gives me negative 8.5. There's no scores that are smaller than that, so there is no outlier. For quartile 3, you look at 9 and you add 10.5, and that gives me 19.5, and there is no score greater than that. So therefore, there's no outlier there either. Okay? I would imagine right about now, the concept of interquartile range, third quartile minus first quartile, you're probably pretty comfortable with, but the notion of outliers you're probably a little fuzzy with. So we're going to keep going